Okay, so next up, we're going to talk about break-even points. Okay, so a break-even point is the number of items sold for which cost and revenue are the same. Okay, in other words, it's when the company neither makes nor loses money. Okay, so when how much you're spending is exactly equal to how much you're earning. Okay, so you're breaking even, you're not making a profit, you're not losing money, it's just even. Okay, so that's going to be the part that we're going to start looking at. Well, why do we care, right? Ideally, you wouldn't want your company to just break even, right? If you're selling a product, you want to be making money, right? Well, break even points are important because it tells you this is what your minimum goal has to be to not lose money, right? So it gives you the idea of like, okay, anything more than this, you're going to make money, and anything less than this, you're going to lose money. Okay, so that's why it's kind of important thing to be working with. So let's look at Mike's situation. So Mike sells sandwiches for $6 a piece, costs him $2 to make a sandwich, plus he has a weekly overhead of $500. So our question is, how many sandwiches does he need to sell in order to break even? And how many does he need to sell in order to make a profit? Okay. All right, so the first thing we're going to do is we are going to define our variables. Okay, so the two things that we're caring about in this problem, or actually the one thing, right, is just the number of sandwiches sold. So the number of sandwiches. That's what we care about. All right, and then we're going to use C and R and P for our three functions for cost, revenue, and profit. So we don't have to worry about defining extra variables for those. Step 2, we're going to write a cost and a revenue equation. So C of X equals, so my cost equation, it costs me $2 to make each sandwich. So how much it costs times the number of sandwiches, plus there's a weekly overhead of $500. So I also am having to pay out $500 a week. Okay, and then my revenue equation, well, I'm selling them for $6 a piece, or Mike is selling them for $6 a piece. So $6 times the number of sandwiches. All right, and what we're looking for in this particular situation is we want to know, when are those two things equal? When does the cost equal the revenue? So I'm just going to set these two equations, cost equal to revenue, and we'll solve it and figure out when that happens. So this should be a pretty easy solve. I'm going to subtract 2x from both sides. So 500 equals 4x. Right, divide both sides by 4, and x is 125. Okay, so how many sandwiches does he need to sell to break even? So he has to sell 125 to break even. Okay, how many does he need to sell to make a profit? More than 125. Okay, so he needs to sell at least 126 to make a profit. Okay, now in this particular instance, right, is that going to get you a big profit if he sells 126 of them? No, right? He's going to be making like a couple of bucks in profit, but he'd technically be making a profit. Okay, so selling 126 should not be the goal of this guy's company, right? He should be shooting for a much higher number than that. But as long as he's at 126 or higher, he's going to be in the black. So that's your minimum goal. All right, next problem that we have here. So Abby makes dolls and she decides she wants to start selling them on Etsy. She knows it costs her about $450 in materials to make each doll. And if she's going to be making a lot of them, she knows she's going to buy a new sewing machine for $350. Okay. Based on how long it takes her to make a doll and how many dolls she's seen online, she estimates that she can sell about 5 of them a month. Okay. So the question here is, how much should she charge for her dolls in order to make a decent profit? Okay. So the first thing I want to point out is that these two problems are different. Okay. This problem, we were asked to find how many sandwiches does he need to sell. So we were asked how many. This problem is asking me how much. Okay, so my variables are going to be different. X is not going to equal the number of dolls here. They told me that it's 5. Okay, so when I go to define my variables, and this is the tricky part, you got to make sure that you pay attention to this, right? I'm not going to use X for the number of dolls. I'm going to use, let's see. I'm going to use No, I guess I'll stick with X. I was thinking about using a different number, but I was going to use P for price, but we're already using that for profit, so it doesn't work out. So I'm going to use X. X is going to be how much she charges per doll. Okay, that is the thing that I'm actually looking for here. All right, so for my cost and revenue equations, so C of X, it's going to be a little bit different, right? Because before it was 2 times X the number of dolls, okay? But I'm sorry, the number of sandwiches. But X isn't the number of dolls in this problem, right? So her cost, it costs her $4.50 in materials per doll. But the number of dolls isn't in question here. I know how many dolls, it's 5. So it's going to be $4.50 times 5, right? And then plus any overhead costs, well, she's going to buy that extra sewing machine, right? So $3.50. That's my cost equation. There's no variable in this cost equation at all. It's just all numbers. My revenue equation, so revenue is how much you're selling them for, which that's what we don't know, right? Your revenue is how much are we selling them for? That's what I'm trying to figure out. Times the number of things that you sell. Well, we do know that. That's 5. Okay, so that's going to be my revenue equation. So I just want you to notice that these kind of setups look different. Okay, so you got to make sure you pay attention for that. All right, but to solve this problem, we're going to solve it the same way. We're talking about making a profit. So the first thing I want to figure out is what does she have to sell just to break even, right? If we can figure out the price to break even, then from there, I can decide how much she should actually sell them for. So that's what I'm going to calculate. I'm going to set my cost equation equal to my revenue equation, and we'll solve that. So this stuff here, that's all just going to get thrown into a calculator. It's all just numbered. So 450 times 5 plus 350, that is 3725 equals X times 5. So I'm going to divide both sides by 5, and that works out to 74.5. Okay, so what does that mean? Well, she's not going to sell 74 and a half dolls. That's dumb, right? So she's going to have to sell at least 75 dolls to make a profit, right? This is one of those instances where you're going to round up kind of no matter what, right? Because you can't make only part of a doll, okay? So, right? Oh, wait, no, I just made the mistake, right? This isn't how many dolls. This is how much, right? See how easy it is to slip into that, right? So in order to make a profit, right, she has to charge more than $74.50 per doll to make a profit. All right, and then from there, to answer this question about how much should she actually charge to make a good profit, well, that's an opinion question. Okay, I mean, you could say $75, but is that going to get you a decent profit? No, it's not. But maybe $100, right? If she sells them for $100, she'll be making about $25 a doll. That's not bad, right? So 5 dolls, that would give you a decent amount of profit. So to answer the actual question of how much should you charge, it's kind of subjective, right? So when I have a question like that you're being asked, yes, you need to answer it, and yes, you need to back it up, okay? But it's not necessarily going to have one right answer. Okay, so big takeaway with this is that you've got to be really careful when you define your variable about what they're actually asking you to find, and where that variable shows up in your equations is going to vary a little bit. Okay, so just make sure that you're being really careful about that.